Saxon Advanced Mathematics, lesson 100. Woohoo, you guys. We have made it. Lesson 100. Now, the sad thing is that we are not together for lesson 100 because what I like to do with my students when we hit lesson 100, and Jayla, we weren't able to do it last year, I like to get my students each a bag of candy. Skittles, M&Ms, Reese's Pieces, something small like that. And I like to count out for you 100 of those candies so that you can get a really nice visual representation of how much homework you have done, how many lessons you have studied, how much work has happened to get you to this amazing point in the year. It's one thing to say, yeah, I did 100 lessons of math. And yeah, you can look through your notebooks. But what a more delicious way to celebrate your journey is to look at a bowl full of tasty tidbits and go, I have done one lesson for every one of these candies, and now I get to eat them all. So what I'm going to ask you to do at the end of this lesson is go root around in your kitchen, talk to your mom, see what you can come up with for a food that you can find 100 of to celebrate your victory over math. 100 baby carrots? I mean, maybe. That doesn't really sound all that celebratory to me. 100 almonds? Maybe. 100 craisins? I could get behind that. 100 chocolate chips? Most definitely. So maybe you've got something on hand. Maybe your mom would be willing to put it on her shopping list, and next time she's at the QFC, she can grab you the candy of your dreams. But I really want you to do something to celebrate this milestone, even though I cannot be there to celebrate it with you. I will remind you again at the end of this lesson, please talk to your mom and get that 100 things. I'd love for you to have a bowl of it when you sit down to do your homework for this lesson so that you'll have it right in front of you and you'll be able to enjoy your lovely snack as you go. Okay, what we're going to do in this lesson is develop some identities from ones that we already have. So the good news is we don't have to learn any new identities. The perhaps less than lovely news is that we're going to have to do some acrobatics with the ones we do know. But that's okay. And here's the thing, because this is the end of what we're doing this year. Again, 100 lessons, you guys, is a phenomenal achievement. Trust me, the kids who are going to traditional classrooms are not studying this much math in a year. There's no way. They can't. They can't keep up. The teachers cannot possibly keep 30 different students, lassoed together and moving in the same direction for 100 lessons. That's nuts. So trust me when I tell you, you are accomplishing way more in our class than those other kids. It's just not possible to cover this much territory in a high school class. College classes will go even faster. Oops. But you're prepared for it. You're ready. I have 100% confidence in you. Okay, so what we're going to do in these examples is we're actually going to develop the identities that John wants us to do. So there's no application of them. We're just developing identities. So example 100.1 is we're going to develop an identity for sine A cosine B. That's what our goal is, right? And what we're going to use, I want you to get your notes handy, are sum and difference identities. I accidentally called those double angles. Don't notice that. The green ones are our sum and difference identities. Sine of A plus B, sine of A minus B, cosine of A plus B, and cosine of A minus B. We don't need any of this other stuff. Okay, that was me practicing. These are the ones that we learned, and then we used these to develop the double angle and the half angle. We don't need the double angle and half angle. We just need these original ones, okay? Now, what I want you to notice, I'm going to write the first two down on my page over here, right? So, B equals, let's see if I can remember it, sine of A cosine of B plus sine of B cosine of A. And then we need the second one too, the A minus B. And that is same combination, but a minus sign. Oops. Now, we're trying to find an identity for this. So we can see, well, look, there it is. It's right in here. So what we're going to do is we're going to simply add these together and look at what happens. It's kind of cool. What we're going to get is the sine of A plus B plus the sine of quantity A minus B. Okay, so that's this side equals, now look what happens over here. This all cancels and we get 2 sine A cosine B. We simply added together the first two of our sum and difference identities. And look how close we are. Now all we have to do is divide it by 2. But what John likes to do over here is say, take this and multiply it by 1/2. That just looks a little cleaner. I agree with him. And so what we can say, because this cancels, so now I'm going to write it all fancy like sine A cosine B equals, I'm just bringing this over here and that over there, 1/2 sine of A plus B plus sine of A minus B. This would be a nightmare to try and memorize as is, but if you just remember, oh, I can get that by just adding those together and doing a quick division. And remember, dividing by 2 is the same thing as multiplying by 1/2. This just makes it look a little neater to write it out. There is our first new, what we call the product identity, because we're multiplying there. Sweet, right? And I'll give you a hint. The first 4 that we're going to do are the harder of the 2. So this is one of the harder ones. Example 101.2. Oh, I'm sorry. Look how I'm jumping ahead. Now we're going to develop the identity for cosine A sine B. Now, I look back to my original 2 and I say, oh, look, that's the other part. Whoopsie. I've written them in the opposite order, but that doesn't matter. I like to keep them in this order when I have them in this identity, and now we're flipping them. That's okay. So this is going to be our next identity that we develop, and we're going to take the same 2 to start with. So I'm going to write them all down again. We get practice in remembering them. And I'm going to keep them in the order that I'm used to working them in. I'll flip them to this order right at the end. This is the one we're developing. And then I'm going to do the minus. I'm not going to put that plus sign there. Wait on that. And it's minus. Okay, now, last time we added them and these 2 canceled out. This time, that's the part we want to keep, right? It's the cosine A, sine B. This is the part we like this time. So I don't want them to cancel each other out. So what we're going to do this time is we're going to subtract the bottom line. You could think of it as we're multiplying it by -1 and adding them, if that helps you. But we're essentially subtracting this bottom row. So look what happens here. Sine quantity A plus B minus sine A minus B equals, now look, this minus this, now this cancels. This turns into a plus, and I get 2 sine B cosine A. And just like before, we're almost there. We just have to divide this by 2. And here what we'll do is multiplied by 1/2 just to make it cleaner. And now to write it better, I'll just do, and now I'll flip these so that they're in the order that we like for this one. Cosine A, sine B, it's the very same thing, just a different order, equals 1/2 times the quantity minus and there is our second identity. Notice that it's really easy to remember what to do if we look at the identity we're trying to develop and look at where that part of the expression, where that expression shows up in the identities we're using, right? It matches to the first part, so we want to keep that part and make the other part go away. That's why we should decide to add them, is because these signs are already opposite and they wipe each other out. Down here, we're interested in the second part of the identity. So we don't want those to cancel each other out. So that's why we use the negative or the subtraction, however you want to think of it, to change the sign of this one. So these will stay and this will cancel. That's how we keep it straight. As we move on to the next ones, you'll recognize what to do. And we know to use the sine identities. Notice we haven't been using the cosine identities yet. But that's because these identities are the ones that have the pattern that we like, right? We wanted sine A, cosine B. Well, there it is. It's in the sine identities. This is what we wanted in the first one, and this is what we wanted in the second one. So that's how we knew to choose. I can do identities all day long, you guys, but sometimes I just can't talk. That's how we knew which ones to choose to develop these identities, is because they had the expressions already built into the other identities. All right, so let's see what else John might like for us to develop. And actually, I mean, I can't give John credit for this. This is into the world of calculus. 100.3, develop the identity for cosine A, cosine B. And these are called product identities because we're multiplying them, in case that wasn't super clear for you. All right, now, as you can guess, okay, we see cosine A, cosine B, and we go back to this page and go, oh, that we're going to get down here with our cosine identities. So we're done with those. We developed this one. We developed that one. Now we're doing this one, and you can guess where we're headed. Okay, so I'm going to write the two cosine sum and difference identities. Cosine of A plus B equals remember, this is the one where the signs flip. And then the other one, feel free to use your sheets as we're doing this. Once you feel like you've pretty solidly memorized this, what I recommend is that maybe when you sit down to do your homework at the beginning, you write them out. But you don't have to write them out every single time you use them now. If you've done the hard work of memorizing, you can work off your notes. You can work off your unit circle. Just go back every now and then, once a day at the absolute most, and make sure that you can still recreate chunks of that. You don't have to recreate every bit every time, but you don't want to lose that hard work, that mental knowledge you have gained. And here we flip the sign again. Okay. So this time, this is the identity we want. And we see, oh, look, there's the portion we want to protect. These are already canceling each other. So again, we can simply add. And we will get cosine A plus B plus cosine A minus B equals, that cancels. And so we get 2 cosine A cosine B. Goodbye. Right? And then the very same thing, we will divide by 2 multiply by 1/2. And what we get is cosine A cosine B equals just about run out of room on these, don't I? Okay, there's our third identity, our third product identity. And that 2 should not be in my puffy cloud of knowledge there. I bumped him out. Okay, and then the fourth one has a little bit, it's a little tricky. We just have to be careful with our minus signs. Sine A, sine B. Again, we recognize this as a component of the cosine sum and difference curves. Identities, curves. I've been talking about parabolas to the algebra 2ers, so sorry. They learned how to graph parabolas today, and that's always a doozy, right? Because first you have to complete the square to get the equation the way you want. Allow me to show you. All right, here's their lesson 100. You get this. You have to rearrange it to complete the square. Then you have to remember the 4 parts, right? The sign tells you whether it's up or down, and then this number tells you blah, 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 and then you have to find the second point. Jayla, those used to make you pull your hair out. But anyway, my brain is all saying those words still. Okay, so this is what we want to do this time. It's the fourth product identity. We recognize this as a component of the cosine sum and difference, so we're going to use those to start. Signs are opposite. Okay. Now, we're using the same methodology. We see that this is the one we want to keep. We want to not allow these to be canceled. So that means we'll want to change this one to a positive. So this will stay positive and this will stay negative. This is a little bit tricky because we're going to make the top one the negative. So we can't really think of it as subtracting like we did last time. We have to think of it more like it's an elimination in a system of equations, where we're going to rewrite this as having the whole beast being multiplied by -1. Okay, the whole thing. And what I'm going to do is I'm going to rewrite it underneath so that we can see it. So it's going to be minus cosine A plus B equals minus cosine A cosine B plus sine A sine B. That's the tricky part. We really can't, this one I said, it's like an elimination where we multiplied by -1, but we can also just see it as a subtraction and let that drive our calculation. This one is trickier because we can't see it as a subtraction. We have to change it and make it an elimination more directly. So I take the time, for this fourth one, I take the time to rewrite it because then it's easy. All right, so now I've got cosine. Okay, this is the positive one. This has become the sum identity has become negative. So I'm going to write the negative one first. Does that make sense? A minus B minus the cosine of A plus B. That's a little tricky, right? I want to write the positive one first and then the one with the minus sign in the middle. Equals, these have now canceled, and here I have 2 sine A sine B. Now I'm on familiar ground. Divide by 2, multiply this beastie by 1/2, write it one more time. Those cancel. sine A sine B equals 1/2 and then a big one there. I just want to double check this one. Yes. This fourth one is the one that's tricky because we rearranged the order of it a bit more than the other two, right? So first we found this one, then we did that one. That just had a slight trick. Then we did this one, and then this one was the one where we have to be super careful. And we can see it's right there because the minus is up top. Last time the minus was down below, so it wasn't so bad. But this one, just go ahead and rewrite that first line after multiplying it by -1, and I think that makes it a lot easier. Okay, puffy clouds of knowledge, our minds are expanding. As you can see, these look hideous if you were just to memorize them. But if you realize, well, I don't have to memorize it, I just have to be able to recreate it out of those crazy sum and difference identities, easy. Easy, I hate to say easy peasy because that sounds ridiculous, but yeah. Okay, take a breath. Now we're done with our product identities and we're gonna switch to more sum and difference with a twist. There's a little bit of mind-blowing business I have to explain at the beginning, and then once we get past that, I think it's okay. So this is, I didn't have the heart to tell you there was a part B to this one, but there is, and it's more sum and difference identities. Again, we're not going to memorize anything new except the process, but we're not going to just memorize the identities. We can use them to create. And again, John shows you a list of all of them. I don't want to do that. I want to jump in. Okay. What we're going to do is we're going to use our old friends, these guys, but we're going to substitute in some different variables. Are you ready? Where we used a plus b before, we're going to use x. And where we used a minus b before, we're going to use y. Now, sometimes students go, what? You, I mean, we all say that a lot, don't we? What? How can you just change it? Well, we did it in the half angle identities, remember? Remember when we changed the a/2 into an x? We can do that. We can say what we were calling, a/2, we're now just gonna call x. Well, now we're saying, okay, a plus b is x. Then I wanna show you something interesting. If we take these two, if we say a plus b equals x, and a minus b equals y, and we add them, look what happens. We get 2a equals x plus y. This feels like what we were doing in the last part, doesn't it? Similar idea. And then we divide by 2. And we can see that I want to change these to equal signs. That's less confusing. A equals x plus y over 2. We're going to use this as well. And then similarly, we're going to say if we say a plus b equals x, and now let's multiply that by -1 and rewrite it as minus a plus b equals -y, right? This is that. multiplied through. Now what happens if we combine that? The a's cancel, and we get 2b equals x minus y. Divide both sides by 2, and we get b equals x minus y over 2. So what we just did is we made two lovely assumptions about how we're going to change, and then we did a quick elimination thing here in order to solve for the a and the b. So now we have variables for, or expressions for x, y, a, and b. All right, we're going to use those. Example 100.5. Develop the identity for sine x plus sine y. Okay, now this is different than our old sine a plus b because they don't have addition in them. We're adding the signs themselves, right? So here's what we're going to do. First, we're going to develop this part, the sine x. We're going to take our old friend, okay? We're going to take this, here's a sum identity with sine. We're going to take our old sum identity with sine, and we're going to do some substituting for it, okay? So this is just our old friend. We're pulling him back, getting the band back together, right? That's that. And now we're going to use these other values, and we're going to do some substituting. And I'm going to work with another pen so that you can see a little bit better what I'm changing. Okay, so what we decided was that a and b, we can call that x. So I'm going to change this to x. A, we agreed we could change into x plus y over 2. And b, we decided could be x minus y over 2. And now I can do the same thing. B, x minus y over 2, and a, x plus y over 2. So now we have an expression for the sine of x. Right? And I'm not going to rewrite it, but you can see I've crossed out the old familiar green parts and I've substituted in the interesting red parts based on these 4 values that we developed together that you were probably like, what are you even doing? This makes no sense. All right? Now, that was for the sine of x. Now we want the sine of y. Y is based on that one. So let's do the same thing. Let's go back and write the original identity the way we've done it. Whoops, I'm getting excited. I changed that into an x. This just has the minus sign. Okay, and then we're going to do the very same thing. A minus b, we said we're going to call that y. I'm going to write these under so I don't get too squishy. A is x plus y over 2. B is x minus y over 2. And then same thing here. Okay, so now we have taken this second expression, right? If this is the first one, there we developed a new sine of x, right? And then if this is the second one, sine of y, that's what we've got right here. So now all we have to do is add these two together and we'll have an identity for that. So look what happens. We just add them, right? So I'm gonna have sine of x plus sine of y equals, now before I write this all down, let's look and see what happens. Sine and cosine, these match, right? And these cancel. So this will equal 2 sine of x plus y over 2 times cosine of x minus y over 2. Make sense? We have 2 of these, and these all cancel. Dare I? There. So this is our identity. Again, I sure wouldn't want to develop that. I wouldn't want to memorize that. But developing it, once we got this, we just substitute them in. It's pretty easy, isn't it? I mean, as much as this could possibly be easy. But you can follow the logic of that. It's a thing of great beauty. Okay. We did the 2 sine. We did the sum and difference for sine. We haven't done these yet, but you'll see we're going to just work those in the very same way. Let's go on to the next one. Example 100.6. Develop the identity. Okay, here we go. Sine x minus sine y. Okay, so we're going to do the same thing. We'll want one for the sine of x and one for the sine of y. Again, we do it substituting into these, but we've already done this. So all we have to do is go right here and copy what we had, right? This is the sine of, let's see, it's x plus y over 2 cosine of x minus y over 2 plus, let's see if I'm getting this right. John, did I do it? Yes. And then for y, it's the same except we have a minus sign there. And let me just remind you of what I'm doing once I write this down. Okay. Just double checking to make sure I got this right. This should be a minus. Yes. What I'm doing for these, I'm just going back and copying what we already created right here. 1 and 2. And remember, we started with the sum and difference identities, and we plugged in these new values that we used. Now I'm just using these again. Last time we added them. This time I want to subtract them. So we're going to subtract this whole bottom row. Now look what's going to happen. We'll get the lovely sine of x minus the sine of y here. That's the easy part. Now that we're subtracting these two that are exactly the same, they're going to cancel. And this is going to get turned into a plus. That's what I got ahead of myself on last time. Now we're going to get 2 double checking to make sure I didn't. The sine has the minus, the cosine has the plus. Yes, this is correct. So we developed the sine of x and the sine of y in this problem, and we added them. And then we took the very same values over here and we subtracted them. Okay? So these are even easier because we can, well, the other ones we used exactly as they are. All right? And now we're ready to do the cosine plus and the cosine minus, and it's going to work the very same way. We'll go back to the beginning and redevelop so that you get a chance to see that again. If your brain is pounding at this point, don't worry. Yikes. Remember, I'll give you a pep talk at the end. If you're hanging on at all, yay, you're doing great. Okay, this time we want to do cosine of x plus cosine of y. So I'm going to use these two identities and I'm going to write them in this form to start with. Okay, those are our tried and true. You memorized those before. There's nothing new about them. Now we're going to go back to this little change in rules that we agreed, and we're going to change x's to a plus b and y's to a minus b. Right? Now we're going to remember these a and b values. A is equal to x plus y over 2. And the b's go to x minus y over 2. Again, that was according to the rules that we developed way back in the very beginning. Okay, so now we've taken our old sum and difference identities and we've rewritten them with these new variables. Now in this particular problem, we want to add them. So we're going to add them here. We're going to get cosine x plus cosine y equals. Now let's stop and just see what's going to cancel here. What's going to cancel is this part, right? Because that's a minus and a plus. So all that is going to go away, and we'll be left with 2 of these. 2 cosine x plus y over 2 cosine x minus y over 2. Right? So this is a third identity. And then for the last one, has your brain exploded yet? We're going to take these same 2 adjusted, but we're going to subtract them this time. Cosine of x minus cosine of y. What I like to do for these problems is when I'm developing the sum, the adding identity, I like to start over and rewrite them fresh. Right? Start with the original identity and fix it up with the x's and the y's. Then when I'm doing the minuses, the subtracting ones, which are a little bit trickier, I like to work with the already adjusted ones. I save myself that little step. I mean, A, because I just did it, but B, because my head is spinning at this point and I just want to be more careful. So cosine of x equals cosine of x plus y over 2. Gracie's snoring. Cosine of x minus y over 2 minus it's getting crowded down here. Whoops, x minus y. Okay, so I'm copying this to this because I'm using the same 2 functions. I just need to subtract them this time. Cosine y equals for the y function, we add. Okay, so now there are my two functions again. Last time I added, this time I want to subtract this one. Okay, so I have to be careful with what's happening. This will become cosine x minus cosine y. That's beautiful, that's just what I want. This minus this is gonna cancel, and this one's minus, and I'm making this one minus. So it's gonna become minus 2 sine of x plus y over 2. I'm really squeezing my space. Let me scooch up a little. Cosine x minus y over, that's a 2, a little bitty 2. You can see it big there. Let me double check and make sure we got it right. Yes, that minus 2 is what comes through loud and clear. In the sum version of the cosine plus cosine, it's a positive 2. In the subtraction version of the cosine cosine, it's a minus 2. That's somewhat pleasing. Okay. Take a minute, breathe, pause me and go splash a little cold water on your face if you feel like that would be helpful. Let me just say that we just demolished lesson 100. That was a really hard lesson. And here's what I want you to take away. I want you to take away the fact that these identities are much easier to develop than they are to memorize. And that having memorized a few, like these 4, we can do a lot of damage, right? We can take those and shake those and reshape them and create all kinds of different things. Double angle, half angle, product, more sum and difference. And that's what calculus and the upper parts of pre-calculus are going to be about, is developing this muscle, this mental muscle to take those identities and shape them. If you don't do anything else, I want you to memorize those sum and difference identities. I want you to get them locked into your brain as best you can. And then just remember, oh yeah, we play these games where we reshape them. But if you memorize these, the reshaping is going to be so much easier. If you get back to another class where you pick up this reshaping business again, but you don't remember the original identities at all, then you're going to have twice as much to learn. So, memorize everything that we've done. Yes, do this, practice this. I'm probably going to ask you to do this in a review problem. Probably not this week because it's brand new, but I may give you a review problem later on because I do want you to invest a little time and energy in this. But we are going to be flipping gears and talking about that crazy acuplacer running start business very soon. So, congratulations. I'm extremely proud of you, all 3 of you. We're done with lesson 100. Please go find some sort of delicious 100th lesson celebratory snack for yourself. I will be asking you what you get. I will be asking you how wild this lesson felt in your brain on a scale of 1 to it hurts and I don't even know what you're talking about. And you can interpret that however you like. But congratulations. Well done, students. Goodbye.